Howdy, welcome to Geometry. This is the video that accompanies assignment A3, which has to do with similar polygons. That is the notation that we will use for similarity. It looks similar to congruence. Remember, if we said two triangles are congruent to each other, we use that notation. This is our similar notation. First off, a definition. What does it mean for two polygons to be similar? It means they have the same shape, but perhaps different sizes. Remember that for triangle congruency, we had no angle congruency. You could have small equilateral triangles. You could have big equilateral triangles. They have the same shape, but perhaps different sizes. So notice two congruent triangles are indeed similar to each other. They have the same shape and the same size. Size is not necessary for similarity. Based on this definition, we can say that two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. So we're going to check to see if two polygons are congruent by checking to see if their corresponding sides are proportional. We won't worry about the corresponding angles too much. Do know that if you have the same number of sides polygons and the corresponding sides all have proportional relationships, then the angles are going to be congruent also, the corresponding angles. So here we have a problem. Are these two triangles similar? And if they are, write a similarity statement. So at this point, I will ask my able-bodied assistant to help us out. Yeah, assistant, huh? Because that's how this is going to be. I'm going to be your assistant from now on. You know, I know more math than you do. You're just nicer. People like you more. Yeah, be nice. Okay. What does he want us to do? Dude wants us to find out if these polygons are similar by comparing the ratios of the corresponding side lengths. So let's go ahead and do AB and compare it to its corresponding side, which is QS. We'll compare side BC's length to the length of side RS, and we'll do the same for side AC and side QS. AB, 3, QS, AB is to QR. 3 is to 7.5, as BC, 5 is to RS, as 5 is to 12.5, and as 4 is to 10. I really shouldn't perhaps have made equal signs here. I really am trying to verify this. I don't know if this is the case yet. I look at my calculator. I type them all in. 3 divided by 7.5, 0.4, yep. And 5 divided by 12.5, 0.4, and 4 divided by 10. Yep, that's 0.4. So they are similar. And since they're similar, I will write triangle ABC is similar to triangle QRS. Right, that looks very familiar. It's saying that side length AB is proportional to the side length QR. The ratio of AB to QR is the same as BC to RS and AC to QS. So these side lengths are all in proportion. Remember that we do have to write these in a different way, or in a particular order. Just like with congruency statements, we want to look at these and know that angle A is congruent to angle Q, B is congruent, angle B is congruent to angle R, angle C is congruent to angle S, as well as which side lengths are proportional to each other. Well, I'm sorry. I never knew that you felt that way. I thought you wanted to be the assistant. I can be the assistant next time.
We've been through this.
Colleague.
Colleague?
Hey, our assistant showed us that yes, these corresponding side lengths do in fact form a proportion. The ratios of the corresponding side lengths do form a proportion, so they are similar. And the next thing we're going to look at is scale factor. And this is a scale factor of two similar polygons. So here we already know that they're similar, and they're asking us to find the scale factor. And there's two ways to do this. We can compare triangle ABC to triangle QRS, or we can compare triangle QRS to triangle ABC. I will, at this point, ask my colleague if he will do this for us on the board. It doesn't really matter, but I came up with these ideas, not him. Okay, anywho. ABC to QRS. How does ABC compare to triangle QRS? It's smaller, huh? This is saying AB2. Remember, you could do something then like side AB to side QR. How does that compare to each other? 3 to 7.5 or 3 over 7.5, 2.5. Nope, 3 divided by 7.5 is 0.4. That's that number we already got. So then when you see the scale factor, you're saying, hey, triangle ABC is 0.4 times smaller than triangle QRS. Okay? How does triangle QRS compare to triangle ABC? Well, clearly it's bigger. How bigger? Let's look at RS over BC. And we have 12.5 divided by 5, 2.5. So 2.5 times bigger. Triangle QRS is 2.5 times bigger. So when you're finding scale factors, just look at the way they want you to do it. Pick one of these sides, divide by this side. Pick one of these sides, divide by this side. And you're going to get different numbers each way, but you should get the same. So for instance, if we came back here, if we did, instead of doing these side lengths divided by this one, we could have done it this way. 12.5 divided by 5, 10 divided by 4, 7.5 divided by 3, and we would have gotten 2.5, and they are similar. Thank you. Thank you. You seem to enjoy that a little bit, actually. Well, gang, hey, that's not so bad. I'm going to give you an assignment. It's going to have six problems on it, maybe. It's going to be, I'm going to give you 6 assignments, and I want you to go enter the answers to the problems into Google Forms. Okay, I will release this to you sometime in the future. It'll be in the past when you look at it.